Dr. Ernesto Liebana. He's a vet surgeon with a PhD in microbiology, and he was a fellow of the Royal College of Pathologists, UK. He worked in research in the area of zoonosis and public health, first as a postdoctoral scientist in the vet science division, and then as a senior vet research officer in the Department of Food and Environmental Safety and Pathology in the Vet Laboratory Agency, UK, where he had primary responsibility over the molecular typing and detection group. His research interests were centered in Mycobacterium bovis, Salmonella, E. coli, Enterococci, and Campylobacter infections, as well as in the development of AMR in these organisms. In 2007, he joined the European Food Safety Authority, where he was dedicated to the scientific coordination of risk assessment activities in the area of biological hazards. In the last 7 years, he holds the role of head of the biological hazards and contaminant unit. He is currently leading the biological hazard team in the BIOHAW unit. Dr. Rieban, please.
Thank you, Mr. Chairman, and good afternoon, everybody in the room and everybody online. It's an honor to be here. In my professional life, I had the fortune to come to Korea. This is my 6th time, and I'm really honored to be in a country that takes antimicrobial resistance so seriously. So I will try with my presentation today to illustrate a bit of the good things, I believe good things we are doing in Europe, and perhaps give some of the scientific reasoning behind the draconian measures that you heard in the previous presentation. In my title of the talk, I refer specifically to the European Food Safety Authority, which is the place where I work. But I realize that more and more every time I stand up and give a presentation, I talk about things that we do in common with the other sister agencies in the EU. That is the ECDC and the EMA, the European Medicines Agency. And I think that tells me that really in the last, let's say, 5 years, the concept of One Health has really engraved in our thinking and in the kind of activities we do. So the first thing I want to mention is about the structures which are there to ensure that we do this together in a team of professionals that have all the necessary knowledge and expertise. Our colleagues in the European Commission established already a few years ago this AMR One Health network, and we meet routinely. And you have then people from all the different compartments, the human public health, the veterinary and food, and also the environmental compartment most recently. And we have discussions and exchange information and best practices. In the latest One Health Action Plan for the EU, this idea of One Health was very much at the center, at core. And also very recently now we had council recommendations adopted, again, where the concept of One Health is very much there. And very importantly, 3 aspects are highlighted there. One is the possible setting of targets for antimicrobial resistance, which is a new concept because we are quite familiar with the concept of targets for use, but targets for resistance is something that has not yet been very frequently used. There is also the notion that all member states should have their national control plans as One Health plans, and also quite some remarks about the improvement on surveillance and what new elements we can add to the surveillance to help us in all these endeavors. So what do we do in EFSA? In EFSA we try to bridge research, monitoring, risk assessment, and policy. I think all these compartments are important. And the first thing we do is we scan what has been published, what is out there from research organizations, and we use that for several things. We use that for the detection of emerging risks. We use that to decide also how to conduct monitoring. We have to go back to the European Commission to explain to them in technical specifications what should be done and how should be done. And we use also the data that we gather from published literature in risk assessments. When we do our risk assessments, there is always this overlap, and the data from monitoring is used in risk assessments, but also the risk assessments help us in data gap identification, which also many times goes back to us funding research and then bringing this back in new monitoring activities. And we want to believe that everything we do, all the EFSA opinions and reports we produce, help the making and implementation of policy and control. So one of the, let's say, paramount activities that we do every year in EFSA on the monitoring of antimicrobial resistance is the production of what we call the European Summary Report. This is an endeavor that is done together with our colleagues in ECDC. So we bring all the data from food-producing animals and foods and data from humans, and we produce this report. This has been done now for many years, more than 10 years. And over time, we have dramatically improved the way we do things and the way we can action on the data we gather. The objectives are very clear. We do the monitoring because there is a public health importance. We don't do this for animal health right now, as I will explain later. We monitor the occurrence of resistance, and we have several things that we looked at. The combined resistance indicators to important antibiotics or critical antibiotics. And a few years ago, we were asked also by our risk managers to try to bring together all these huge data sets into some succinct indicators that could give us a way into understanding how different countries were making progress or not in the implementation of the control plans. And two of those indicators that we found quite useful so far is what we call complete susceptibility in indicator E. coli and also prevalence of ESBL producers. So we compute these indicators, we present the data using different data visualization tools, maps, and we also do trend analysis. What is very important is by applying all this methodology and presenting the data in the way we do, there is no hiding. Everybody can see what is the situation in a country in the north of Europe, in the south of Europe, in the east or in the west. And you can see who are the good guys and who are the bad guys. And sorry, there is nothing you can do to prevent showing that. And if we want progress, you have to first understand which pockets of inactivity or in which countries progress is due or not. So that is very important for us. The latest report is the 2021, and you can consult it in our website. The link is there for you. And we survey animal species in a 2 years cycle. So not every year countries have to put all the resources into surveying all the animal populations. That would be a bit unrealistic. And the beauty of our system has been that we really achieve full harmonization. And we do that through also the good collaboration with our European reference laboratory on AMR, and they are also responsible for training the laboratories that perform the testing and also for conducting quality assurance and proficiency testing trials. And the testing is not done by EFSA. This is a decentralized system, so the national reference laboratories are the ones doing the actual testing and then reporting in a harmonized way the data to EFSA. We analyze the data and we produce the reports. One of the important changes that we introduced recently is that since 2021, on voluntary basis, it is now possible for certain type of data to be generated using whole genome sequencing and not only phenotypic testing as it has been the case until that year. We have done a lot of effort also into trying to produce this report in a more modern way, because it has become a very thick document with many pages, many tables, and let's be honest, sometimes it's a bit difficult to read. So we have progressed quite a lot into producing these story maps, and these story maps have different audiences. They can be useful for those that do not understand anything about resistance but want to know a bit more, but they can also be useful for those that understand the topic and want to dig a bit deeper into the data. So I invite you again to click on those links. I don't have time today to show it to you, and you will see the nice efforts into disseminating of information we have done. But most importantly, for those that really want to use the data for risk assessments or other scientific purposes, we also are developing dashboards. So now you don't even need to read the report. You can select the type of indicator. We have only done it so far for these key indicators that I mentioned before, but soon we will have the full data set in this kind of dashboards. So you can then select the substance or the indicator of interest, the country or the group of countries, and you can generate your own map or your own graph. So you are independent from having to look the report or come back to us with a question. So that is about the data on resistance. But of course, it was already a number of years ago evident that if we gather data on resistance and we sit on it and do nothing, our policymakers or risk managers do not have a lot of evidence to put control options in place. So because the way we were gathering data on use or consumption and on resistance in animals and in humans was scattered across different institutions in Europe, we got years ago this mandate to integrate the data analysis from the two sources and the two compartments. And this was the beginning of a group of reports that we call GCFA reports. We are about to release the fourth of these reports. And year after year, we have been making the most of the data available, increasing the complexity of the statistic analysis we do. But basically, in a nutshell, it has shown that there is a very nice correlation between the amount of use of antimicrobials and the amount of resistance that you find. And especially if you use this indicator that we call complete susceptibility, there is almost a perfect correlation between those countries that are high users, where you have a very low percentage of fully sensitive strains, and vice versa. We also, in this report, present very transparently the data on usage in animals and in humans, and we have performed also trend analysis on that. And you can see the green light on the slide is the data showing the amount of use of antimicrobials in animals, while the blue one is the one for humans. So significant efforts done in the animal sector, for reasons that I will explain later, where nothing really changed or a slight increase on use in the human sector. So after 4 reports, as I mentioned, the overall conclusions have always been more or less the same. That interventions to reduce consumption will have a beneficial impact on antimicrobial resistance, and that we need to promote, both in humans and food production animals, the prudent use of antimicrobial agents, and also encourage infection prevention and control. There is no denial that there are pockets where there are still high levels of consumption and high levels of resistance, even in Europe. So interventions need to be reinforced, and there is still a long way to go. So that was really the basis for policymakers to start thinking about what to do to reduce the need to use antimicrobials and subsequently reduce the use of antimicrobials in animals. And this is the data from the latest report from our sister agency, EMA, where you can see a really significant and very encouraging decreasing trend in consumption in food production animals. And we have this very aspirational target by 2030 to reduce the overall use by 50%. So in Europe, we believe this is the way to go. And countries are taking it seriously and putting their interventions that can be used for that. Again, EFSA and EMA, a few years ago, I realize now that this is quite some years ago, put together this report, and I think the field has not moved much, where we really analyzed best practice and all the scientific evidence on what to do to reduce the need to use antimicrobials. This is what we call the RONAFA report. And we came back with 3 areas for action: reduction, replacement, and rethinking. And some of the most prominent recommended control options that we had in that report was the setting of targets. It was quite clear those European countries that set targets for use achieved those targets and had a positive outcome in the overall resistance picture, for example, the Netherlands, Denmark, and other countries. We also were very much aware of the industry interest for developing alternatives to antimicrobials, and there are a plethora of that, from vaccination to bacteriophages, immunomodulators, feed additives, many things that could help also overall in this picture. The problem with that is that the regulatory context, how industry could send applications for those products and get them authorized, was not clear, and is still not clear. So this is an area for improvement. And rethinking the way we raise our food production animals. And again, very recently in Europe, there has been a huge push to increase animal welfare. And EFSA has been producing in the last year and a half a lot of opinions on animal welfare. And I think rethinking how we raise our animals, how we provide environments that give them better lives, also has an impact in reducing how prone they are to acquire infections, and therefore the need to use antimicrobials. So all of this fed into all the regulations that you heard in the talk before, and as I mentioned, we have these aspirational targets for the what we call EU Green Deal, or the Farm to Fork strategy. Recently also we received from the European Parliament a mandate to look at what could be the impact of transporting animals in the spread of antimicrobial resistance. Because when animals leave the farm, if they have a different status on their let's say, colonization by resistance bacteria, they could be shedding them and spreading them to others which were either less contaminated or even naive. So there's a number of recommendations on this opinion, amongst them minimizing the transport duration, which is also quite linked to welfare, the good cleaning and disinfection of vehicles, and also quite an interesting idea that came here, which is the logistic transport, and is whether you can find out something about the status of your animals before they leave the farm to the abattoir or the farm to market posts, in order to decide when to transport them and at what moment, for example, of the day to slaughter them, in the same way you would do with Salmonella or Campylobacter contaminated animals. So that's, again, a little idea that is there about starting to reflect on targets for resistant antimicrobials. Moving on to a different compartment, which is the environmental compartment. We realized also that we knew very little about this, and in the case of EFSA, we only have responsibility about the food production environments. We are not talking about the environment at large. So the Biological Hazards Panel back in 21 proposed a self-task to our executive director, and we came out with this opinion where we mapped all the sources and transmission routes for all plant-based foods, aquaculture, and terrestrial animals. And some of the things that came out of this massive review, not surprisingly, was the contamination with fecal matter for fertilizers and irrigation water, feed and humans as a source of resistant bacteria to farm animals, and water in general. Several mitigation strategies were proposed, reducing the bacterial content in general of manure, sewage, and irrigation and aquacultural water, preventing transmission in general from animals and from surfaces. Again, the issue of cleaning and disinfection, and water features very high in all of these. And there was a recommendation really to have a multiple barrier approach for water. We also were aware, and this came as also conclusions in several other international reports, of the large number of gaps, of the fact that there were not very many detailed studies in the EU, and the lack of systematic studies in general. And that is why we recently published call for a project. In this case, it's specifically looking into the role of water, reclaimed water for irrigation, and recycled water for handling and processing of food of non-animal origin in this case, where we have different objectives on new methods development and understanding what could be the role of this type of water in the spread of resistance through the food chain. And this is in the context of really water being a dramatically valuable resource and all the problems we are having with that in Europe. So this contract hopefully will be awarded soon. We are at this moment evaluating the proposals received, and then we will be working together with our contractors for a couple of years and hopefully yielding interesting results. Another topic that we are working on together with a plethora of agencies is the issue of fungicide resistance, in particular azole fungicides. And this is a health issue because it has been seen that in certain areas there is an increase in the rate of infections with Aspergillus resistant strains in humans. And this may be due to the therapeutic use of the antifungals, or it can be due to environmental exposure. And we are trying to shed a bit of light on that. The problem is that the use of these fungicides and the residues in the environment comes from 4 different regulatory regimes. In the case of plant protection products, so pesticides, this is under responsibility of EFSA, but we also have biocides, which are under the responsibility of the European Chemical Agency. Also as industrial chemicals, also under the responsibility of ECHA, or they could be also veterinary medicines, in which case they are under EMA. So we got all together in a mandate that came from Commission, and all these agencies, plus the Joint Research Center, which is generating some data, are working together in order to address some questions. And basically is whether we can identify a causative link between the environmental use of these substances and resistance developments, assessing the risk, identifying the risk factors, and then also what type of studies, giving advice on what type of studies could be provided by applicants for the approval of these substances. And finally, identifying data gaps and research needs. So if you're interested in this topic, again, watch the space. The report, interagency report, will come out in July 24. So we only have a few months ahead of us to complete this work. Something we have also been wondering about, and especially our Commission colleagues wanted some advice from EFSA to defend the European position in the international context, is the issue of use of antibiotics as plant protection products to treat plant bacterial diseases. And it is recognized that these plant pathogenic bacteria are responsible for major losses to crops worldwide, and that in general the use in crop is considered to be very low as compared to other uses. Like, for example, in Europe it is forbidden. You can only use them under very, very concrete scenarios and under emergency situations. However, also there are several papers out there showing that the use may not be as succinct or as low as we believe, and that it may be more widespread. So we commissioned also, we commissioned a study in this case to look at all the available existing information on the use in plants. Those are the pathogenic bacteria that are most commonly used for. Erwinia, some Pseudomonas, and some Xanthomonas. And in this case, in our procured project, we wanted to know what is the concern on the release of these antibiotics in the environment and whether they could have an influence in the amount of resistance found for these bacterial pathogens, and also whether there are some events on horizontal gene transfer that have been already detected and published somewhere. And we didn't, in this case, have the time or the resource to go into looking also in soil bacteria, but that is something that we want to do in the future. So this report that was commissioned to the University of Louvain in Belgium has got a very nice summary of information across different parts of the world and what is the situation there on the use of these substances. And it also covers some of the information on genetic determinants and also on alternatives and innovative treatment for the control of plant pathogenic bacteria. So again, go to our webpage and look for the Plantibio project, and you can find all the information there. I'm moving towards the end. We were also asked about a couple of years ago by the European Commission to do a thorough review of the existing information and to categorize the animal pathogens according to the risk on antimicrobial resistance development. So a number of opinions were published, produced in this case by the Animal Health and Welfare Panel for the different animal species, and those were the microorganisms that were found to be most relevant from the AMR point of view. After that, we were asked by the Commission also to apply criteria in the European Animal Health Law to see whether these should be listed as microorganisms for which routine monitoring should be conducted in Europe. Unfortunately, this animal health law is not very conducive to the type of questions one should ask for resistance, and because we were strictly applying the terms of reference we got from the Commission, the outcome of all these assessments was uncertain, meaning that in the end there was a decision in Europe not to do harmonized monitoring at European level for any of those microorganisms. And in the recent Council recommendations, there is this sentence that says Europe should continue to assess on the basis of follow-up of recent scientific opinions the animal diseases caused by bacterial resistance to antimicrobials to see if there is the need to list in the future any of those diseases. But so far, nothing will be mandated to us on this. However, at member state level, individual countries, they are programs on monitoring of resistance for some of these microorganisms also. EFSA is not involved in that case in the analysis or reporting. And yes, it has been mentioned also recently how important it is also to improve the communication and the education of stakeholders in all these matters. And again, we have been quite active in the last few years in producing a number of education and communication materials with reports, with podcasts, with videos, with infographics, etc., etc. And I think it's a nice way of really testing whether the public understands what we do and understands the message we want to put out there. So my final remarks, I'm done. I think I showed many examples on why this One Health approach is essential for AMR. I think I also showed that it's very important to have these increased partnerships between research funding bodies, including ourselves, risk assessors and risk managers. And I didn't have a lot of time to talk about it, but I think my colleague René will be doing it tomorrow. How important it is also to incorporate new technologies to the way we monitor. This is something new, and it gives these genomic techniques really give us a much more power to identify the transmission and movement of genetic elements and determinants. So we seriously believe this will make a difference in the whole situation. And that's it from me, so I will be happy to answer any questions you may have.
Thank you, Dr. Rivera. Now it's time to discuss. Any questions or comments from the floor, please?
Thank you so much for the very science-based evidence presentation. I want to ask, it's great achievement that EU member states, some of them have already reduced by 50, the MU by 50% in animal health and food producing animal health sector. Do you have any implications on animal welfare issues in, during the process of that reduction. I ask this question because as World Organization for Animal Health, we are, WA and our members are to maintain the good quality of veterinary service and animal welfare in the process of fighting AMR and reducing AMU. So I think, and at the same time, I know that the EU is a well-known advocate for animal welfare as well. So I'm sure you have good practical examples how you convince the field veterinarians, for example. What were the reactions by the producers on the ground? So is there any good examples of the process of the reduction? Thank you.
Yeah, I think perhaps several examples come to mind. It is true that every time there is one of these drastic decisions taken, like it was the ban of growth promotion, or like in the Netherlands, the setting of targets that were very stringent, or the red card mechanism that my colleague from Denmark mentioned, there is a certain level of resistance from industry, and always the concern number one raised is will go against animal welfare. In practical terms, industry adapts, and what happens is that they continue to produce at a profitable, with a profitable margin and complying with those things. So there are a certain number of adaptations that need to be taken place, and I think history tells us that it is possible. It is true that nowadays we have published very recent work on animal welfare that has implications also, which are far more, let's say, ambitious than only reducing antimicrobials, like reducing dramatically the density, the stock density, or giving a number of other things that will put the industry at the difficulty to continue to produce at the price they are doing now. But I don't think this will increase only the welfare of the animals. It will just most likely end up with a price tag that the consumer would need to pay. But on the concrete use of restricting unnecessary use of antimicrobials, I think on growth promotion, I think on the restrictions on prophylactic use that were advocated by EMA reports, etc., we don't have any evidence that at least in Europe, has resulted in a decrease in welfare of our animals.